Devin dropped the class, and Thad has never responded to my emails.
The guy that was here last week?
Yeah, Devin dropped out.
I don't remember Devin.
Oh, I didn't know that.
Yeah.
He texted me this morning.
Oh, all right. Do I just do two problems at a time?
Sure. I'm down with that.
All right. I guess I can take the first one. Oh, yeah. Taking it easy one. I said constant but non-zero. The extreme force would be 0. And the reason why is because the acceleration can be 0 with the mass. So it makes it the red's 0, but that object can still be moving. It's just not accelerating.
I said that.
That makes sense.
That
Sorry,
makes sense.
I need water. It's just pretty much the formula where AM equals F, you know? So if A is 0, then the rest is 0, but it could still be moving. It just it's not accelerating.
As long as the velocity is constant. No
In the same
acceleration.
direction.
Yeah.
Mm-hmm. Yeah, because if you change direction, that's accelerating.
Yeah, just making sure that that was in there.
Oh, yeah. And then we got the next one, number 2. So it's pretty much the plug and chug. So you got the total force is 50. Mass, so it wants you to find the mass. And then it gives, and if you want, I feel like it's kind of easy enough. We got 56 kilograms.
Yep.
Yep.
Mm-hmm.
Woo!
Nope.
Sweet.
Oh, I was like, wait, no, you didn't get that?
No, I got that.
Part B, we stated if the vehicle is part of the system, then its mass would have to be taken into account by having another source besides the ship exert the force. Then the ship would not be recoiled. That was kind of hard to explain, but that makes sense. Like you just have to have the outside force.
Yeah.
It's like if he was holding like a compressed gas canister or something like CO2 or whatever, and then it was released. Like it has nothing to do with the ship whatsoever, but it would exert a force. So
Yeah.
Yeah. Sweet.
All
Who
right.
wants the next 2?
I can take them, I guess. So it says, so 3 is talking about a powerful motorcycle. So for this one, I put, for the thing I put mass, it was mass times acceleration. So it was, hold on, I'm looking at my handwriting, it's terrible. 90, wow, hold on. Where'd I get that? 90 times 3.5 is 4, sorry, hold on. My handwriting's terrible. But the answer I got is 1,257.
that's what I got.
Sweet.
Okay, cool.
Yeah, and then you sig figs, so there's 3 sig figs. So it's 1,260.
Yeah. Sorry. 3 sig figs about that. And then the other one is, or 4 is an American football lineman. I said, using Newton's laws, I said, basically, if one lineman pushes greater against the other, then it'll be able to push him back. And then my free body diagram is basically like a guy, like one block pushing another block with a stronger force or the other way, if that makes sense.
I think the mass of the individual, like if they both have the same, like, I mean the acceleration, whatever. the mass of the player what makes the difference.
Yeah. Yeah.
Keyword and
Sorry.
that one. No, it's fine.
Yeah, I have a different wording, but yeah. It's basically that. All right.
You pass.
All right. Who wants the next two?
I
can do 'em.
Next to,
Oh. Go for it.
okay.
What was that? You want me to go?
Yeah, go ahead.
Okay. So for 5, let's make sure I have the question pulled up too. To look at. So A was, what is the force of friction between the losing players? I got 692.
Yep.
Okay. And then B, what forces the winning player exert on the ground? I had 932.
Yep.
And then C, draw a sketch of the situation.
Guys, because I thought I was doing all of these wrong. So
That's good. And then C, I wasn't, I don't know, I drew a little sketch, but I don't know if it's really that great.
What's
So
the stick-figure animation?
yeah, so it's just kind of showing, yeah, the system of them interacting together. But and the free body diagram, you know, where you have, I did like one where you do the boxes with the arrows too, going in different directions.
Yeah.
But
That's the simplest thing. Just make boxes.
yeah, I don't know who's, if you, Bran, is like the best. Thank you for submitting it, but like mine does not look pretty, so I don't know if we want to submit submit mine, but my. But like, I mean, I can do it, but my work isn't the neatest, and I feel like our teachers, I got docked on a point or something for my work not looking neat or something. I don't know.
Really?
But, so
You like
anyway,
it's like
number
100%.
6. Let's see. Number 6, what is the tension in the rope if he climbs at a constant speed? I got 588.
Yes.
And then B, what is the tension in the rope if he accelerates upward at a rate of 1.5? I got 678.
Yep.
Woo!
I got.
We're on a roll.
We're doing good so far.
All right. I will take these next two.
Oh yeah.
Number 7 for part A. Let's see what's what is the mass of the airplane? I got 98,067, which I rounded to 99,900 kilograms.
I think you want to.
Yep.
Okay, yeah, yep.
That's what I got.
I use different equations for the net force, like net force equals force minus friction, equals mass times acceleration, and then plugged and chugged in there. You use the mass of the airplane, and how did I stop? Oh, yeah. Okay, sorry. And then I got 17,200.
Was that for part B or?
For part B.
Okay.
Did we get that?
Is that
Yeah,
what you guys got?
I got 17,200. What? Yeah.
Rounded. It was like 17,185.
Yeah, I rounded up too.
Okay. Yeah.
Right. Yeah, right.
I got 17,300, but I'm just checking my math right now.
200.
Okay, I see where I went wrong.
17. And then C. Sorry, like, all right.
It's just like simple box diagram with going one way and then friction going another way. has like vector and the airplane, and one has the mass of just the airplane.
Sounds good.
Number 8. For A, I got 840 newtons.
Yep.
And then for B, I got 3,400 newtons.
3,400.
That was for 8B.
Yeah.
3,400.
I got 6872.
I got 6872 as well.
Oh, snap.
Let me check my math. Just like double what I have.
You divided by 2. You divided by 2. That's fine.
What was your A again? What'd you get for A?
838.
Yeah, so you do that divided by the sine of 7 then.
Not divided by 2.
I don't
Yeah,
believe
the angle changes to 7
Yeah.
in B.
What equation you guys used for the first one?
What was that?
What equation did you guys use?
So I just did the 12,000 sine of 2.
Yep. That's what I did.
Okay, one second.
Then I got 838. We'll round it up.
It was
7 times the sine of 2 is only 418. Have is tension equals divided by 2 times the sine of the angle. Divide by 2 on the second part.
this part. Is that what you got?
Because I think what it is it gives you like the total force, but only half of it is exerted on the car because the other half is exerted on the tree.
Does anyone oppose that? Everyone's dead quiet.
I'm thinking.
I don't know. Yeah, that's. I mean, that's. I think that's all you have to do is to.
I'm thinking.
Okay.
Question to see if what's in it.
Well, that was
Open crease force. 2.0. I think it would be 830, 837 or 838.
Yeah.
Because we would do the 12.
no, we're fine on that, but the speed.
Well, you
So
do
which
it the
one?
same. I mean,
Yeah, it's the same formula.
What?
But how did you 12,000 times the sine of 220? So how did you get it to 838 without multiplying it by 2?
oh, I did multiply it by 2.
Yeah.
Okay, then you have to divide the other equation by 2 if you're using the same equation.
trying to think why I said that.
Yeah, same here. I don't know why two or three of us didn't do that.
Yeah.
Oh, they got to.
You will still apply the force from point A to its center. But if you did times it by 2, wouldn't you have already times it by 2 in the first equation?
The first equation you do, but the second one you don't.
Yeah.
That's backwards. Maybe it's back.
I know. That's embarrassing.
Oh
So
yeah.
you use that equation, the same force, you still have to, you put like 840 divided by 2 times the sine of, you still have to divide it by 2. Because it's like a different,
Yeah, I don't know.
If it helps. On physics.com, it says our answer is correct.
Good for physics.com.
Pulled out the trump card. All right. Calm down, settle down.
Number 9.
what did we agree on an answer? I'm pretty right.
So which one would it be then?
Yeah, that's fine.
$3,000.
Okay. I'm still confused about that, but I can probably ask him during office hours too about it.
Yeah, that's good.
So I'm okay with that.
Did anyone do 9?
I was gonna ask you
I
guys
didn't get
about 9
9.
actually.
I did not even know how to approach this problem.
See that I was gonna ask you guys because I'm like I have no idea.
Yeah, I didn't do it. Honestly, I didn't even get to like 9 or 11. 10 was super easy because it's just a conceptual question, but I didn't do 9 or 11 because I like ran out of time. I was like,
See, I did all of them except for 9.
Same.
Yeah, I tried 11. 9 I didn't really get, so I somewhat looked at it and I put out like all my variables, but that's it. I didn't know where to go.
Yeah, I figured out that 11 is actually like, it was in like the video about stress and strain.
Yeah.
Figure out how to
Well, what do we get for 10 and 11, and we'll come back to 9.
Yeah.
10
Air could
is
be.
that
Yeah, go
air
for
can
it.
be compressed, but liquids can't.
Yep.
The air is just compressing, so the liquid can expand. And if there's no air in the bottle, the liquid expands and
Yeah.
so the
Exactly.
gas cannot.
Yeah, I see that.
And then 11, did 11?
11.
I can explain if you guys don't have it.
11, I got 0.2 millimeters.
My math might have been wrong.
What'd you get? You're breaking up. I can
Really
barely.
small.
Yeah.
I got like 0.0003 millimeters.
0.003.
0003.
See, I got 0.0002 meters, but then I converted it to millimeters.
Converted to millimeters, and it's still that small.
Yeah.
See what I didn't get the answer. I got stuck at. So I got the force or the hold on. I got the acceleration.
What'd you get as the force?
400,
Like
4,626.
Okay, so I got 4,630 for the force.
how did you guys get that number?
Would
Maybe I
that be
did it
sig
wrong.
figs? Oh yeah. Would be 4,630 because of sig figs.
Oh, yeah.
Okay, yeah, then that's what I got.
Explain how you got that.
Yeah,
So
so
it would be-
forces. Yeah, go ahead.
So I got it would be the total mass. So it'd be 72 plus
470, just
you know,
472.
commas plus 400, and then that you add those together and you times it by 9.8.
Okay.
Or just mass times gravity. 472
Yeah.
kilograms times 9.81.
Mm-hmm.
Yeah, I got that. I was a step ahead.
And then for the acceleration, did you get 0.0707?
Yeah.
Okay.
Yeah, so 0.07069, but then yeah, so you do the force times the length in meters.
Force times the length in meters. See, this is I have it all written out.
Over, yeah, I'm trying to make sure I did this right. And then over
And then what would it be over? It would be over the acceleration. This is where I got stumped.
Okay.
I thought it'd just be over the acceleration, and then I got 1.37, but I don't think that's right.
no,
You don't need
do.
the acceleration in this equation. You need the area.
Mhm.
A is for area. The acceleration is the acceleration due to gravity, which we already put in.
Okay.
I just want to explain. I'm trying to figure out now.
So if you do the force divided by the area, let's see. That might be where I got it wrong.
So you have to know the force of steel, right?
Yeah. And that's
Which is
in the
200.
book.
So yeah, 200 times 10 to the 9th. So you do it over 200 times 10 to the 9th times your area, which is the 0.07069. That's what I
Okay.
did. And that came out as 0.0002 meters, which is also 0.2 millimeters.
What did you do for the?
So
So
40
to find the stress, you have to find force over area. So what did you guys get for the area?
The 0.07069, the one we talked about earlier.
Yeah.
So in that, you got
Yes. 0.07069.
That's 6 zeros and then 312. Right? Is that what you got for the answer?
For the answer, let me just do it one more time.
I'm like a little thing in the backpack.
Oh, no worry.
Yeah, I got 0.000199, which is 0.0002, and then also converts to 0.2 millimeters.
Okay, I can see how you got that answer.
Yeah?
Yeah, that's what I got when I did it on my calculator anyway.
Sweet.
Guys, I'm trying to figure out number 9.
Does that make sense, Brianna?
What? Sorry, one second. I'm reworking the problem because I realized where I messed up on one spot.
Yeah, I followed you guys through those steps, and I just barely finished it on my calculator, and that's what I got as well.
Sweet.
So the elasticity of steel is 200 times 10 to the ninth.
Yes.
Yeah. I want to try and work 9. I'll help you with working 9 right now. I'm gonna Google it, see what they got, because I'm confused.
So you gotta use the sine with a 35-degree angle to figure the rest of the math out. I know that at least.
Yeah.
Still did not get the same answer.
What?
Did you
What was
find the area of the cylinder he's standing on?
Are you still talking 11? The area?
Yeah. Mhm.
0.07069 meters squared.
Not 8. Oh.
So
That's
just
like,
pi r squared.
yeah, that's the area of a circle.
Be more
Pi
elaborate.
0.150 squared.
Yeah, but it says it's a cylinder. So do we have to find the area of the cylinder or just the circle he's standing on?
Well, it's the radius that is a cylinder.
Well, a cylinder is like a can. The height, I think.
All right. You know it's serious when people are not talking.
Yeah.
Is that what you guys use for the area?
What was that?
Is that what you guys use to get the area?
Which one? The pi.
Area equals 2 pi RH plus 2 pi R squared.
No, I just did pi r squared.
Mm-hmm.
That's the area of a circle, though, and it says the area of a equivalent to a steel cylinder. So I think that the area was not correct.
But even if it's a cylinder, you're still just doing the radius of it. You don't have to worry about height.
But the question says, how much was the antenna compressed if we consider it to be equivalent to a steel cylinder?
It doesn't, you know.
0.150 meters in radius.
Yeah, because it doesn't force forward.
Yeah, because we have the radius and the height, so you can find the area of it.
Oh, that's true. If you have that graph. Should we look on? Gosh. There's all. Calculate it with the if you have the area of the cylinder, like try applying that the height and width and see what results you get. Man, this is annoying. $29.7. Fine. That's fine. How's it going on 9?
Sucks. I'm still trying to figure out if this is right or not.
Okay, wait, so cosine, let's see.
So I tried looking online to see if there's anything on number 9. I still don't get it. I don't know if any of you guys have been working on it as well.
I found answers, but I don't know if those are correct.
Yeah, and he's gonna want the work.
Yeah.
No.
I'm still trying to
Well-
figure out how you do it. That's the biggest question.
Yeah.
Why don't you? I mean, I understand they have the sign. Like you're trying to find the force of the rope by using the sign, and then you got to use the force that she exerts on the rock. Would be. I'm assuming that would be that cosine.
Okay, I think I figured one out.
Cosine.
I just found this step-by-step PowerPoint for it. So let's see how this
Yeah.
works.
Hallelujah.
Where's that?
I'll send you a thing. I'll send it in.
What was the answers on the PowerPoint? I'm curious. What's the answers on the PowerPoint?
I'm not sure. I'll send it to you though. I just found it. So I just want to see how you do it. I don't understand. So
No, it's good.
oh shoot, it doesn't give you everything. Dang it.
No, something else.
Ten to the ninth. 10 to the ninth. 200 times 10 to the ninth. Did you send it?
Yeah, I sent it. Is it in the group chat or?
Oh.
Oh, okay, here we go. Just load it up for me.
Awesome.
That's a complicated looking diagram.
Beautiful.
Yeah, it somewhat shows. I'm still trying to figure this out. I'm trying to write it out while I'm looking at this thing.
Okay, so he has sine and cosine.
Mm-hmm.
Correct. I found.
That's not the color line.
That's not, no, it's just for A. So I just don't understand why you do that, but I guess you do. Wait, okay. That makes sense. Okay, so you're doing sine. I guess so. You're doing the opposite over here, and then the cosine, which is.
I'm guessing you just do it because it's a triangle.
Is that what it is?
I think
So
so.
why cosine? Why is it not tangent? Degrees to get the force of the opposite hypotenuse.
What? I didn't hear you. I'm sorry.
The formula, I guess that's it.
Yeah.
I'm trying to understand the formula, but it doesn't.
I don't know.
Because you got math. I guess sine 15 makes.
You're totally breaking up. I didn't hear anything you just said.
I didn't either.
Oh, sorry. I guess mass equals cosine and sine.
I think so.
Yeah.
According to this PowerPoint, that's what it looks like.
All right. Did you get for B? Did you get for B 273?
For B? Yeah. That's what I got.
I guess I need to look at this.
I got
Figure it out,
273.
What's wrong again?
No.
And then for the first one, did you get 512 then?
It's 512.1 noon.
Okay. Got 512. Oh, 0.1, yeah. I don't know, to me, this one's just confusing, so.
Yeah.
I'm definitely gonna have to spend some time looking at this PowerPoint some more. Like,
Yeah.
Do we want Brian to send it up again? The answers.
Click the wrong button. My bad.
Jared, if you want to send the answers this week, did you get all of them down?
I didn't write some of them down. Like, my handwriting's really terrible, but if you want, I can rewrite it and submit it.
I can send it. If you want to send me a picture of the last page.
The last page? For 11?
Like, what is your work for 11? Number 4, kind of like.
I'm sorry, I didn't hear that.
So, can you send number 4 and number 11?
Sure thing.
And then I'll scan it all in. I think I got that.
Do we need to post on the computer? Like the group posts? Okay. If you guys want, like, we can take like a day, figure out number 9 about it. We can.
Okay.
I think if we want to try to figure out why, but whatever.
Or we can just do it on our own.
Yeah, on our own. I have questions.
Okay, do you want, so you have a number, you just want me to send 4 and 11 to you? Okay, I'll send them to you once I get to a scanner, so.
I can send you a picture of my 11.2 on the group chat.
Okay, that would be good.
Okay.
Just to show you what I did, I guess. But so
Yeah, that would be good. I feel like I'm doing it right, but I just keep getting different numbers, so I don't.
yeah, I mean it's gonna be a very, very small number too. Like,
Mm-hmm.
and that's why like 0.2 millimeters, that actually makes sense because obviously it's not going to be compressed like a meter or a foot or or something like that. So
Yeah.
So, and I mean, you're really just doing the cross-sectional area of the cylinder, so maybe that's what makes the difference too. I don't know. So,
Mm-hmm.
but here, I'll take a picture and send it to the text you just sent out.
Yeah,
So.
just like the equations you use are completely different. If you're just using cross-sectional area, then you just need to find the area of the circle. But if you're doing,
And that's what it is. So.
Right, like because the equation for I think surface area is like the really long equation we're talking about there. I think cross-sectional area is literally just like the area of the circle. But it's,
Okay, that makes
I think
sense. I would use that.
Yeah.
I was still getting an answer though, even when I did that. So I would like to see.
Yeah. So I just sent it. So look at, I mean, that's kind of some of the work. So, but if you
Okay,
can decipher it. But,
I'm pretty good at doing that. Okay,
Hey.
guys,
All right.
in time next
Sounds-
week.
yeah. That
Sounds
should work
good.
fine. So.
All right.
All right. I'll scan those in. I'll send it to you.
Okay, bye.
Thank
Okay,
you.
thank you.
All right. Thanks, guys.
Bye.
Bye.
All right, see you later.